Welcome to The Explainer. Today, we're diving into a breakthrough that's teaching AI something we do all the time without even thinking about it: how to imagine.
You probably picture the paths, right? The turns, the dead ends. You create this mental image. But for a long time, AI couldn't do that. It was trying to solve the maze blindfolded.
Okay, so let's dive into this by taking a look at how AI has traditionally tried to solve these kinds of complex problems. For years, a technique called chain of thought, or COT, has been incredibly powerful. It allows AIs to tackle things like logic and math problems by basically writing out their reasoning step by step. The problem is, this whole method has a critical blind spot: spatial reasoning. We're talking about anything that involves navigating or understanding layouts in the real world. That's where it really falls down. So, for example, in a test called Frozen Lake, these COT models consistently get lost. Why? Because they just can't accurately picture the environment from text descriptions alone. They get totally confused.
So if the old way is so flawed, where do we find a better model? Well, it turns out the answer is right inside our own heads.
You see, humans think seamlessly in both words and images. There's this concept called the dual coding theory, and it's absolutely crucial for how we navigate and understand the physical world around us.
And inspired by this human ability, researchers asked a really key question that, well, it led to a pretty major breakthrough. What if, instead of just thinking in text, an AI could actually generate its own mental images as part of its reasoning process? And this illustrates the solution so perfectly. It's called Multimodal Visualization-of-Thought, or MVoT. And what it does is it allows the AI to generate both text and images as its reasoning. So, MVoT is this whole new paradigm where the AI doesn't just describe the next step, it visually imagines it. It actually generates an image of the new state. The process itself is this powerful loop. The model thinks in words, then it visualizes the outcome of that thought, and then it uses that new image to inform its next verbal thought. It's pretty amazing. So let's move on and see how this new method actually builds a much more robust and reliable AI thinker. Researchers put MVoT up against code in 3 really challenging spatial tasks: everything from simple navigation all the way to complex interactions in dynamic environments. Now, what's really interesting here is this slide reveals exactly why the old method fails. It turns out that code T just gets hopelessly lost trying to track coordinates in text. It's just not built for it. And the results are pretty dramatic. I mean, on the most complex task, MVT's accuracy is substantially higher because it can visually track the environment instead of relying on these flawed text descriptions. So, the crucial point here is that this isn't just some small improvement. It's a fundamentally more robust way for an AI to reason about the world. Yeah, in the toughest scenarios, MVoT beat the text-only approach by more than 20%. That just goes to show you it's way more stable as the environments get more complex. And that's the key. Unlike COT, MVoT's performance doesn't just crumble when the grid size gets larger or more hazards are added. It's simply a more reliable reasoner. And for us humans, this is a huge deal. It's far more interpretable. We can follow along with the AI's visual thought process, which makes it way easier to trust and, to debug. Now, this breakthrough isn't just about solving puzzles. It has absolutely massive implications for the future of artificial intelligence. I mean, think about it. An AI that can visualize its reasoning could be applied to robotics, autonomous driving, even creative design. It could lead to way more capable and much safer systems across the board. This marks a really fundamental shift from an AI that's just a language processor to one that's a visual thinker. And that opens up a whole new frontier of possibilities, which leaves us with one big question. If an AI can now imagine, what will it create next?